Okay, let's learn about differential equations. So a differential equation in two variables, usually x and y, involves x, y, and derivatives of y. That's the new part. And an important skill is figuring out if an equation that you're given is a solution of a differential equation. This is a differential equation because it has that second derivative of y in it. So to test it, let's do this. Let's figure out the second derivative of this equation, put it in there, and see if we get 0. Okay, so y prime is going to be negative 4e to the negative x. Y double prime is going to be the negative of that, which is positive 4e to the negative x. So y double prime minus y is going to be 4e to the negative x minus y, which is that, and we get 0. So yes, it is a solution. Okay, in this problem, we have a given differential equation, and we want to verify that this equation is the solution of it, and then we're going to find a particular solution. And to do that, they're going to give us an initial condition for y and for x, and we're going to use these to figure out what c is right there. So here we go. We have x, y prime minus 3y. Well, there's x, there's y. We're going to take the derivative to get y prime. So y prime is going to be 3cx squared. I'm going to plug this into my differential equation. So x times y prime minus 3y and we're going to see what we get. That's going to give me 3cx cubed minus 3cx cubed equals 0. That's what's supposed to happen. So yes, this is a solution. Now we're going to plug in 2 for y and negative 3 for x to get c. So 2 will equal c times negative 3 cubed. So 2 equals negative 27c. So negative 2/27 equals c. So the particular solution is y equals negative 2/27 x cubed. This is the solution that works for this differential equation given that initial condition. Here's another example using trig functions. And we're supposed to verify that this solution works for this differential equation. Okay, so y prime is going to be 3c1. Okay, and then I have to take the derivative of sine, which is cosine of 3x plus 3c2, and the derivative of cosine is negative sine 3x, which gives me 3c1 cosine 3x minus 3c2 sine 3x. Now my differential equation has y double prime, so I'm going to take the derivative one more time. And the derivative of cosine is negative sine, and chain rule says I have to multiply by the derivative of 3x. I'm going to get negative 9 c1 sine 3x minus 9 c2 cosine 3x. Okay, that's y double prime. So y double prime plus 9y is going to be all of this minus y. Oh, minus 9y. So I need to put a 9 in front. Yep. There we go. Okay, so I have a negative 9c1 sine 3x minus, oh, that's a plus. Yep, plus 9y, plus a 9c1, so that cancels. I have a negative 9c2 cosine 3x plus a 9c2. So that cancels, so yes, it works. Okay, now we're going to plug in pi over 6 for x when y equals 19. Okay, so I'm going to put that into the y equation. 19 is equal to c1 sine of 3 times pi over 6 plus c2 cosine of 3 times pi over 6. Well, the cosine of pi over 2 is 0, so this whole term disappears. And this is 1, so I just found c1. Then it also says that y prime equals 18 when x equals pi over 6. So I'm going to go to my y prime equation right here, and I'm going to put in 18. And that's going to be 3 times c1, which is 19, cosine 3 pi over 6 minus 3c2 sine 3 pi over 6. And once again, the cosine of pi over 2 is 0, so this whole term disappears. That is 1. So I get 18 equals negative 3 c2, so negative 6 is c2. So what's our particular solution? Y prime is equal to 19 sine 3x minus 6 cosine 3x. Okay, we can use integration to find general solutions of the differential equation if we aren't given the general solution. And the way we do it is we separate the variables. In other words, I get all the x's together on one side and all the y's on the other. So to do that, I'm going to multiply both sides of this by dx. So I have dy equals x over 20 plus x squared dx. And then I integrate both sides. So the integral of 1 dy is y. And the integral of this, I'm going to have to do a u du. I'm going to let u equal the denominator. So du is 2x dx. So I need to put a 2x there and a 1/2 there. So I get 1/2 the integral of 1 over u du. And the antiderivative of 1 over u is the natural log of u plus c. So y equals 1/2 the natural log of 20 plus x squared plus c. And that's the general solution of that differential equation. And here's one more example. So I'm going to separate the variables by multiplying both sides by dx. Integrate. The integral of 1 dy is y. I'm going to do a u du again. U equals 11x. Du is 11 dx. So I need to have an 11 inside, so a 1/11 outside. And now I get the sine of u du. And the antiderivative of sine is negative cosine. And my final answer, y equals negative 1/11 cosine of 11x plus c.